Welcome back. Till now you saw various distribution to test the numerical data. Now let us learn the chi-square, and the chi-square is deals with categorical data. There are two distributions in the chi-square. The first one is goodness of fit. The goodness of fit determines the sample you are observing really matches the population. So it has the null hypothesis. There is no significant difference between the observed and expected value. And in case of alternate hypothesis, yes, there is a difference, significant difference exists. And the formula for this one is O for observed, E for expected. So this is the formula. And this is the graph looks like for the various degree of freedom. The other hypothesis for the chi-square is test for independence. So it compares two variables in contingency table, that is the table obtained by summary of two categorical variables, and see if they are related or not. So null hypothesis say the two categorical variables are independent. It means there is no associations and there is no dependency. Alternate hypothesis say the two categorical variables are dependent. It means there is association. The example is, suppose if you are looking at say marks of a course, say mathematics, and in the gender. So does the really gender matter in the marks obtained in mathematics? So these are the questions can be answered by this chi-square test of independence. And here again the formula is O minus E square by E, O for observed, E for expected. And this is obtained like this. I will show you during the hands-on. Degree of freedom is R minus 1, C minus 1, where R is number of rows and C number of columns. Okay. So this is the two things. And a few of the use cases, as I say, mostly that if you have the two categorical variable, if you want to find it out whether there is independence, it will really matters. The way I have explained the example, that does the gender matter when you get a marks in a class, or does the gender matter when you say qualify for admission in a university? Does the gender matter when you become a pilot? Does the gender matter when you hold a top post like CEO, CFO, and so on? These are the few things. Okay. Now let us go and do the hands-on for the chi-square. So we'll do the hands-on, and for the hands-on, please open the Excel file and please go to the chi-square tab. See, these are the sample that have been copied, taken from the internet, and the references there at the reference section. Let me explain one. So this is saying that 256 visual artists were surveyed to find it out their zodiac sign. The result was Aries 29, Taurus 24, and so on. And it has been said that test the hypothesis that zodiac signs are evenly distributed across visual artists. This is the hypothesis we have to test it. This is the questions, that zodiac signs are evenly distributed. Okay. So let us go and start. So in case of category, we have, these are the 12 category, and these are the observed data which we have got it from here. And expected, it is saying evenly. Evenly expected means, see how we have got it. So total how much we have, this much. Let us see, let me sum it. And I sum it, I'm getting 256. So total 256 divided by 12. It means expected should have been this much. Now we have to figure it out whether it is evenly distributed or not. Okay. So which is the chi-square where we are trying to do? This one. Test of independence. and this is the goodness of fit. Okay. So this is the goodness of fit we are trying to test. Okay. So O, we have got it. E is here. So O minus E square, because this is the formula, O minus E square, and this is the we have calculated O minus E square, and this is divided by E. When you when we sum it up, we get 5.09. And when we take the degree of freedom over here, how to test it? In case of chi-square table PDF we have, and the degree of freedom, how much we have. So degree of freedom, if you recollect here, degree of freedom it was, how to find it out here, row minus 1, column minus 1. So here row we have 12 minus 1, that is 11, and 2 columns equals 2 minus 1, 1, it is 11. So 11 each degree of freedom, 11 is degree of freedom, and the chi-square, this is the 5.09. 5.09, and if we are testing at the 95% confidence, that is the 0.05%. So this chi-square, it should have been 19.65, okay, but we have got this one, and this is much less than 19.65. It means this critical value is within the acceptance region. The meaning of it that we do not have enough evidence to reject the null hypothesis. Okay, so we cannot reject. So what is the meaning of this? So it means null hypothesis is true. So there is no significant difference between the observed and expected value. So what we can say, that we were seeing that it is having evenly distribution. Yes, no. So what is the meaning of that? There is not much difference. So yes, this was expected, and this is observed. There is not much difference. Okay, this is not much difference. Okay, so this is the outcome. Now this is the classwork. Please go ahead and do it. And here I have given the questions that a student population, there is a remaining student, the 20% resident and 80% non-resident. And if you have taken a sample of 100 students, that gives you 16% resident and 84% non-resident. How good the fit of this is here, assuming that 20% resident and 80% non-resident. So please try to do the chi-square goodness of fit in the similar way, and without looking the answer. And once you have done it, you can match the answer which is hidden here. If you do it like this, if you do unhide, you will see the answer over here. Okay. So without looking at the answer, please solve it. Now for the test of independency, this is the questions that a random sample of 395 people were surveyed, and each person were asked to report highest education level they obtained. Here is the data. So this is the gender, male, female, and someone say high school, bachelor, master, PhD, and so on. The question comes, does the gender really matter with this is the degrees? Okay. So these are the data given. So this is the data given. So this is observed data. And then we have to do, this is the observed data. We have to find it out, E for expectation. And E for expectation, if you see, how can we find it out, E for expectation? So E for expectation, this is the, if you see the formula, we have given F38. Okay, so 38 is over here. Here F38. This, okay, into B40. B40 is over the total sum divided by F40. This is the base. So expected value, this has been done, this into this divided by this. This is also had a given here over here. Over here, if you see, row total into column total divided by total sample size. So over here, F38 is the row total, B40 is the column total divided by A40, that is the complete sample size. This is how expectation has been obtained. Now, if you see, this is how we are going to do. So here we had the formula. Again, O minus E square divided by E. If you see, O minus E square divided by E. So this is what it has got. And when we take the total, this is what the statistics, the critical value, we have got it. And here, for this critical value, what is the degree of freedom we have? R minus 2 minus 1, 1, 1 into 4 minus 1, 3, 1 into 3, 3. So for 3, this is the degree of freedom. So for 3 at 5%, 7.85. So our 8 is greater than 7.85. So what is the meaning of this? See, so our 8, that is somewhere here. It means it is in the rejection region. It means we have got enough evidence to reject that 0. It means we have to reject that 0. So when we reject that 0, it means this is the true. It says that two categorical variables are independent. Okay. So what is the independent means? It means it does not depend upon the gender. The degree does not depend upon the gender. Okay. This is what the outcome is. Now, this is one more classwork. You please do it after this video. This is the data, please do it. And answer is also hidden over here. If you do the unhide, you will see the answer. But you see the answer after solving on your own. And if there is any questions, please write it in the discussion board. Thanks. I hope you have learned. Otherwise, let me know if you have any questions. Thanks a lot. Thanks a lot for watching this. See you in the next one.